Swayam Prabha. Digital India. Educated India.
We will see that why we don't need to keep the duration of the activity continuous. We should be able to, and that is one of the powers of the precedence diagramming method. We should be able to take the duration, or we should be able to take the start of an activity, finish of an activity, and take it as separate events. And as I mentioned in the last lecture, this is what the AOA representation could do, and we are trying to bring that into the PDM representation. So here is where PDM starts differing from the AON. Okay, the typical AON. So let's take this network. We have 3 activities A, B, C. We have the durations are shown 10, 15, and 30, and we are now going to do the forward pass, which is 0, 10, and then as we come back here, we have the next activity. So to 4, we have the early start of 4, and B goes to so 4 plus 15 goes to 19. From 10 plus 2, we are going to 12. So 19 controls. So 4 and 19, that's good. And then we go to C. Now here we have 4 and a lag of 4, that goes to 8 for the early start. And here we have 8 plus 30 gives 38 as the early finish. And here we get to 19 and 4 as 23, and obviously 38 controls. So we go with the end as 38. Now on the backward pass, you can see we get to 38 as the late finish. Late start goes to 8, and when I take it back on the finish relationship, I get 34. That is 38 minus 4, 34. And if I went with 34 and 15, I would get 19. But if I go through this relationship for the start of B, I would get 8 minus 4, which is 4. So in the backward pass, the minimum value control, so this would be 4 and 34. And let me go back one more step. So we go back here, the 4 goes to 0, and 34 goes to 32. Okay, so we can see that this is the solved forward pass, backward pass network, and there are some interesting results we should discuss here. So number one, we can see that if we are going to apply a rule for what is critical, you can see that of course start of A is critical, start of B is critical, start of C is critical, but when you go to the end of A, activity ending on A, or activity A ending is not critical. It has a difference between the early finish and the late finish. Okay, so this difference now, so my start is critical, but my ending is not critical. So this is where we are differing from the activity on node, where once an activity was critical, the entire activity had to be critical. So this gives more flexibility. Okay, but with the flexibility, like we discussed last time, comes more complexity. So here we can see that the start of A is critical, the start of B is critical, start of C is critical, finish of C is critical, but finish of A and finish of B are not critical. Now we will talk later as to what does this mean in reality. How does, I mean, from an analytical sense, does it mean just I have to start B and move on, or does it mean more than that? We will discuss that. Now we can see a second scenario where what I have changed is actually the duration of B. Okay, if you compare the first one and the second one, almost all the relationships are the same, except that the duration of B is now increased to 35. Okay, with this scenario, now we are trying to see how does the analysis go. You can see it's again 0, 10, and here because we have an increased duration, now it's 35 plus 4, that goes to 39, and we go to C, we go to 8, and now instead of 38 controlling, because we are because the 39 with the finish of 4 goes to 43, that is controlling the criticality of the project. And based on this, we get 43 as the project duration. We do the backward pass as earlier, and now because of this increased duration, we find that while start of A is critical, start of B is critical, end of B is critical, and the start of C stopped becoming critical. Now what has become is the end of C has become critical. The start of C has float. So obviously I could start C on the 10th day, so my duration of 30 now need not be continuous. I could either stretch it, or I could do intermittently what is required. So this is what is the way this can be implemented. But if I don't finish at this particular juncture, I will certainly delay the project. So similarly with A, while the start of A is critical, the end of A is not critical. So this is a variation, and it's something which we have to learn to manage. Okay, now we come to another scenario, which is again quite different and interesting. I've added one more activity D. Okay, so there are changes in the value from the last scenario, where we have now 4 activities. All the durations are 10. I have a start relationship here with all of them. So A to B start of 20, B to C start of 20, and C to D start of 20. And we don't have an A to B finish, but we have from A to C a finish, B to C a finish, and C to D a finish, as it can be seen here. Okay, and if I go ahead and do the forward pass, goes to 20. Here we go to 20 plus 10 is 30 there, and then we are moving further on to C, and then on to D, and you have got the early starts and the early finish of all the activities. So we now start the backward pass. We go to 70 and 60. I'm going to go through this. I think you should be able to follow it with your working. So we go 60 40, 60 20, and 10 0. And now if we look at what are the activities, how does the critical path go, you will see that, or what are the events that are critical. You will see that it's the events which are the start of A is critical, end of A is critical, yes, the whole of A is critical. We have start of B critical, end of B is not critical, start of C is critical, end of C is critical, okay, 40 40, 60 60, and here again start and end of D is critical. But what is interesting is, if you look at C, while the start is critical and the end is critical, you can see that the duration of C can be as much as 20. Okay, so C has to start on 40, it can't delay the start on 40, it has to finish on 60, but in between it has 20 days to do what C needs to do, which C needs only 10 days to do. So here is another scenario where you are able to see that, able to show that the criticality is now not only in terms of start, in terms of end, also in terms of the activity. So when we now move on to float, so obviously this leads us to a discussion on float. Now how do we define float with respect to a precedence diagramming method? And while you will see many textbooks which define the standard total float and free float, as in the case of AON, you can see that when you have behavior like this in a network, some of these the standard AON floats are not so relevant. In fact, it's an open question, is interfering and independent float, how are they relevant, or do they actually, what do they mean in the context of a PDM? But more interestingly, when PDM was developed, they defined these floats here, what is called a start float, the finish float, relation float, and activity float. So based on seeing our earlier networks, you might have developed some intuitive sense on what the start float is or what a finish float is, okay, and even like in C there is something what we are calling like an activity float, but also realize that each of these relationships also have floats defined in the context of PDM. So this is also something which we need to understand. So if we come into the float definitions in PDM, okay, getting into a little bit more of the formulae and the formal. So if we take a total float, so this is actually the activity float. I would call it activity float or total float of a PDM activity. Basically it's late finish, okay, minus early start minus the duration. Okay, late finish minus early start minus the duration. And if you take the start float, okay, which is the float that is coming, the start float, it is it's fairly easy to see, it's late start minus early start. If you take a finish float, it's late finish minus early finish, and you might have, like I said earlier, got an intuitive sense of this seeing the earlier scenarios which we developed. Okay, so the start float can be different from the finish float, and the activity or total float can also be different. Like in the last case, we did not have zero start float, zero finish float, but we had some activity or total float. Now, we also now have relationship floats, and these get quite interesting in the way they are defined. So if I have an activity I and j, my relation float, so I have a finish start relationship here. My relationship float will be, for a finish start, will be late start of j, okay, late start of j minus early finish of I minus early finish of I minus the lag value. Okay, so this is for a finish start relationship. For a start relationship, we would go, so here is the start relationship. I go with the late start of j minus the early start of I, again minus the lag in the relationship. Okay, so this is the relationship float for start. For a finish relationship, I go with late finish of j minus the early finish of I, okay, minus the lag, and which we don't use too much. Okay, the start finish relationship, okay, for definition's sake, we are going to go with the start finish relationship. It's late finish of j here minus early start of I minus again the lag. So these, when you compute in the network, in the precedence network, will give you the relationship floats. Now let us take a look at how do we look at these floats in the context of the problems we have solved. Okay, so we had this network which we had solved earlier. So here we can see 0, so there is no start float, okay, there is 22 days of finish float, and if I do 32 minus 0 minus 10, there would be again 22 days of activity float, okay, or total float. So that is something which we are so we have three kinds of basic float, and then we can also calculate the relationship floats for each case. So here we have a start, and here we are going with, so if we take a start relationship, I have to take the late start minus the early start here, and there is 4 minus 0 minus 4, that will be this. There is no float on this, and you can see that this is also on the critical, it's one of the critical relationships. Okay, similarly here we would go 8 minus 4 minus 4, again no float on this relationship. If we take another relationship, so okay, so now we have, if we take the start float of B, again no start float of B, but finish float we have 34 minus 19 as the finish float of B, and activity float 34 minus 4 minus 15 is the activity float of B. So that is how we would calculate the floats again. Again, C has no start float, no finish float, but let us look at the finish float here. Okay, so we have here 38, which is the late finish, minus 19, okay, minus 4. So, that would be the way this is calculated for the finish activity, and we have seen all of this in the formulae here. Okay. So, if we are going to do for a finish activity, it is late finish of j minus early finish of I minus lag. Okay. Late finish of j minus early finish of the predecessor minus the lag. Okay. So, I would want you to calculate these values, and we will put up these, I mean you should do the calculation and we will put up these values with a part of the slides in the end of the slide, the end of the handout. Okay. So, again I am giving this as an exercise. You should be able to calculate the different floats for this scenario, which we calculated also, and you should be able to check your answers with what we have. Okay. Now, this is the scenario we discussed where we said C has start and end float. Okay. C start float and end float is 0. Okay. Let me go through putting the values like we did last time. So, C has no start float, 40-40, no end float, but activity float is 60 minus 40 minus 10. So, it has activity float. Okay. So, this is, so we have to learn how to interpret this and what this means in the practical context if you want to apply PDM. That is one reason why there is intricacy when you apply the PDM onto a real project. If you look at, so you can again go through these activities, and we have discussed the starts being critical or the ends being critical, and you can now check whether the float values match what we discussed earlier, and you will be able to check the values with the results at the end of the handouts.